guys, so welcome to another lesson, and in this lesson I'll cover the following. So by the end of this lesson you should be able to know how to find the mass of maybe a certain compound or reactant if they have only given you the density and the volume. Okay, and then I also talk about two ways of finding the limiting reagent. Okay, I'll show you the two ways that you can use to find the limiting reagent, and then also talk about how to find the mass or the moles of the reactant that is in excess. And then lastly, I'll talk about how to find the percentage yield. So now, before I go even any further, let me begin by explaining to you what the limiting reagent is. Okay, because you first need to know what it is before you even start knowing how to find it. Okay, and most of the questions in stoichiometry or on more concept, they require you to find the limiting reagent. It's very important. There are some questions which maybe might come with like 10 marks. Maybe might tell you maybe finding the percentage yield. They won't tell you that you need to find the limiting reagent. So it will be up to you to find the limiting reagent. So it's very important in a chemical reaction, especially on stoichiometry. Before you even go any further, you know what your limiting reagent is. Now, let me proceed and explain it to you. Okay, so imagine we have a chemical reaction. Maybe we have A plus B, and then they're giving us a product that is AB. Okay, they're giving us a product that is AB. So let's say maybe this one is balanced by 1, this one is balanced by 2, and this one by 3. Okay, so now, so remember, these products that we get here depend on these two. Okay, for the product to be formed, these two have to react. If one of the reactant isn't there, the reaction won't take place. The product won't be formed. Okay, does it make sense? That's what happens behind the hood of a chemical reaction. So the reactant have to react. Okay, the two reactants, whatever, maybe even if you had oxygen, yeah, maybe like hydrogen, for whatever product you're getting to be produced, they have to react. Meaning that both reactants need to be present. None of them should be absent. Okay. So now, in a chemical reaction, it is not always that the quantity of the reactant that is A and that is A are the same. Sometimes it happens that maybe the amount of this reactant A, it is less than the one that is A. Okay. So let's say maybe like there's like 2 grams of reactant A, and reactant B there is like maybe like 4 grams. Okay, so meaning that as the reaction goes on, it will reach to a point whereby this one depletes because it isn't a lot. Okay, it isn't a lot, and then the one that is a lot, it will remain alone because it is in excess. Okay, it is said to be in excess because they are just a lot. Imagine just like the way it is. Imagine like in the world. Imagine in the world. Let's say maybe they are like 1 million. They are like 1 million. They are like 1 million. 1 million girls. And then there are like 2 million. 2 million guys. Okay, or let me say dudes, or should I say men? Okay, so just know that I think let me just say boys. Okay, let me just say boys. Okay, so imagine we have a population of like 1 million girls and 2 million boys. So now, if it were like a protocol, like or a law that every guy should only marry one girl. Okay, every guy should just marry one girl, meaning that they should just be a pair, not more than. They shouldn't be anything like polygamism. polygamy. Now imagine how many girls can be married. All the girls, right? Because there are 1 million girls on the planet, meaning that from the guys, the number of guys, 1 million guys will be married, right? And then how many now will remain as bachelors? We are going to have another 1 million. Okay, another 1 million. Now, since these guys or boys, they don't have any, they don't have any girl to be paired with because all the girls have already been gotten. They have been used up. Okay, they have been taken. They are in excess because for marriage to happen or for pairing to happen, every guy should be paired with a girl. Now, what if there is no girl present? It can't take place, right? Marriage can't take place. So they'll live bachelors. They'll be just bachelors. That's how it is even for reactants. If the one is in excess and then the one is not in excess, the one is the other one is in small portions, then the other one is in large portions. As the reaction goes on, the one that is in small portions will deplete, and the one that is in a large portion will just remain alone. The same way these guys can remain. Okay, they can remain single forever. That's how it is even for the reactants, or for the chemical reactions. So now, let's go back to the scenario A. So if you look at the way it is here, so now who are limiting the, who are giving the limit, or what is bringing the limit of these guys who are single to remain single? What is limiting them? It is the number of girls, right? It's the number of girls who are not in excess, who are very few. Okay, so these are limiting the other guys to also be involved, right? To be paired. So since they are limited, even now in the chemical reaction, so the one that is in small portion, it limits the other one because once it depletes, there won't be any reaction. Even the reaction will end. The product will just be the same. That's what it means. So since they are limiting, they are called the limiting reagents. Okay, so that's where the word limiting reagent comes from. Because they are the one that limit. Once they just depletes, no matter what, the chemical reaction won't go anywhere. These guys will just remain single. They just remain bachelors, like the 1 million guys in the example. And I hope that it is making sense now. And the reactant that remains without having anybody to react with, like these other guys here, they are called they are said to be in excess. They are said to be in excess. So this is how it goes. So in the question, they will ask you, find the limiting reagents now. How do you do it? So now, oftenly in a question, let me just say, always in a question, they will give you the mass of this, or they will give you they will give you any information that you can use to find the number of moles of the reacting, the reacting reactants or compounds. In every question, they'll give you those details. Sometimes they might not give you the number of moles directly. Maybe they might give you the mass, meaning that you have to use the formula, or you have to find the number of moles using the mass given. Sometimes they might give you maybe the density, like in the question that I'm going to solve, where they give the density and the volume, and they wanted you now to find the mass. Then after finding the mass, then you now find the number of moles. Sometimes they might give you like the concentration. You know that concentration is equal to the number of moles over volume. They might give you the concentration and the volume. Maybe they might say that, okay, like hydrogen that reacted at the concentration on this and volume on this, they still want you to find the number of moles. So for us to determine the limiting reagent, we need to know the number of moles of the reactants, or the products that are reacting, or the elements that are reacting. So that's the protocol. Like all the methods that are used, they require you to know the number of moles. So every time you see a question, it should be tickling in your mind that, okay, what's the number of moles of these reactants? You should be asking yourself that question. So then after you find the number of moles of each, okay, you are now going to use some the stoichiometric coefficients. Let's say maybe you have like, okay, let me just write it again, a plus b, you're getting ab. Let's say maybe this is balanced by 2. I think, okay, these numbers I'm putting in front, I'm just putting them randomly. Okay, this is just an example. So after this, maybe you find that the number of moles of A it is like 2 moles, and the number of 2B is like 3 moles. So the standard way of finding the limiting reagent is to do this. So first you're going to get your first reactant. Using the number of moles of the first reactant, you're going to find the number of moles of the reactant that is having the elements that are found. I mean, that is having the elements that are found in the reactant A and B. Okay, so in our case, you're going to get the product that has been produced, and it is having the elements that are both in A and B. If you don't understand, don't worry, I'll solve an example. I'll show you a realistic question. Okay, so you're going to get, let's say I found that A has got 2 moles, so I'm going to say, okay, what is the coefficient of A? What is in front of A? It is 1, right? You write 1. Okay, and what is the coefficient of this product? Because oftenly you'll be having maybe like 2 product. So you choose the product where with some elements that are in A and B are present. Okay, so in our case it is this one A. Then you write the number that is in front, that is 3. Okay, that is 3. And then now here you put the number of moles that are already known for A, that is 2, on the side of A, of the coefficient of A. And then now you put x for the number of moles that you are looking for. Then you cross multiply. Okay, then you cross multiply. So when you cross multiply, you're going to have like 6 moles, right? So you found the number of moles of this product using the first reactant. After you do that, you go now to the second reactant. In our case here, let's say maybe like 2B. Don't worry, I'll solve a realistic example. So you just write the coefficient, which is 2, and then for this one, use the same product. Okay, don't use a different product. Use the same one that is having elements for A and B. So this one has got 3A, and then let's say maybe the number of moles for this, it is 3 moles. For B, it is 3 moles. So you write 3A, and then you say x representing the moles that aren't known. Then you cross multiply, you're going to have 2x, then equal to 9. When you divide through by 2, you're going to get x as 9 over 2. Okay, so these are the number of moles. So now by doing this, it will mean that if this one reacted with this one alone, it would have produced this number of moles. And if this one A reacted with this one alone, it would have produced this number of moles. Now it will be for you to see now. It will be for you to see that, okay, which one is the smallest A? Which one is the smallest? You'll find that the smallest is this one A, which was when we are using the number of moles for 2B to find for this compound A. So now, since this one is the smallest, it means that if it were to react alone, it would finish first. Okay, it would be depleted first, leaving this one alone. So you even say that this one, since it has the lowest number of moles, it will be considered to be the limiting reagent, and the one that is having the highest, it will be considered to be the one that is in excess. Now if you don't understand that, now let me just quickly dive in the example. So here is the question that we are going to solve. So the question is saying that barium peroxide, which is represented by this formula A, reacts with hydrochloric acid, represented by this formula, to give hydrogen peroxide, represented by this formula, and barium chloride, represented by this formula. So you know that there are 2 products and 2 reactants. Okay, so in a particular experiment, it was planned to treat 145, this is grams, 145 grams of barium peroxide with 25.5 millimeters of hydrochloric acid solutions containing 0.0277 grams of hydrochloric acid per milligrams. Okay, so now they're saying that first write the balanced chemical equation for the reaction, and then secondly they're saying that which one is the limiting reagent, okay, or reactant. They're saying that the question C, they're saying that what mass in grams of hydrogen peroxide, which is represented by this formula A, should result. Okay, so they want you to find this mass, and then question D, it is saying that how many grams of the reactant in excess will be left over. Okay, and then the last question is saying that if 1.34 grams of barium chloride were produced, calculate the percentage yield for barium chloride. So let's first go back to the equation, we analyze it. Okay, so every time you see such a question, you first need to write the equation. Okay, so you need to write the equation and you balance it. Balancing the equation is very important, and if you're in my tutorial group, I've already told how to balance the equation. Okay, so first you need to balance, and actually in this question they have even given you the formulas. Sometimes they might not even give you like the chemical formulas for compounds. Like in this case, hydrochloric acid, they can just say hydrochloric acid, and they would want you to come up with the formula. And so even naming of compounds is very important. You need to know it. Okay, so when you look at the equation, they're saying that barium peroxide, so as your first reactant you have barium peroxide. It is peroxide, right? So barium peroxide, it reacted with what? Hydrochloric acid. Okay, hydrochloric acid, that is going to be plus HCl to give hydrogen peroxide. Now they have said that to give, so meaning that these two reacted to give these two, and actually this one here, it is solid because of the presence of barium, and this one here, it will be an aqueous. The state symbols are very important, they also carry some marks. Okay, and then they have said that they reacted to give us the hydrogen peroxide, which is written like this: hydrogen peroxide 2A, and it is also aqueous. And then they have said that even barium chloride, which is just written like this, okay, so this is the equation. Now it should be balanced. If the equation is not balanced, whatever answers you'll be getting will be wrong. Okay, before you continue with solving, make sure that the equation is balanced, and make sure that the state symbols are represented, because your lecturers want to see this. Okay, now let me just balance it quickly. Okay, so to balance this, we just add 2 in front A. Okay, now question B, they have said that which one is the limiting reactant or limiting reagent. Remember, I said that the first thing that you need to do is to know the number of moles of these two, the barium peroxide, and the hydrochloric acid. Okay, so you're going to use dimensional analysis. So right now they have given you in the equation that barium peroxide, it had the mass of 1.45 grams, right? 1.5 grams. And then you can find now the molar mass of barium oxide, and once you find, you're going to figure out that it is going to be, let me call it MR, the mister, representing the molar mass. So the molar mass of barium peroxide, it is going to give you 169.3 grams per mole. Okay, so now you have these details, so you can easily use dimensional analysis. So meaning that you're going to say If your lecturer allows you to use the formula, which is number of moles is equal to mass over volume, you can proceed and use it. But most of the lecturers don't use this formula at tertiary level. Okay, they mark it wrong. You need to check the book of Zumda and Raymond. They use dimensional analysis. It is the standard way of finding the number of moles, and you should normalize using it. You need to be practicing using dimensional analysis. If you don't know how to use dimensional analysis to find the number of moles, you need to contact me. I have a video in my tutorial group. Okay, maybe some other time I might record it on this channel, but you need to learn it. Okay, so using dimensional analysis, first you're going to write 1.45 grams 1.45 grams times, so you have this, which is 169, it is 0.3, right? Yeah, 0.3 here. So you're going to say that times 1 mole over 169.3 grams. Okay, so now the grams are going to cancel. You're just going to remain with 145 times 1 mole, which is going to give you 1.45 moles over 169.3. Okay, and then now you're going to divide this into this, and you should get, you're going to get 0.008565, like this. So even write moles. Don't forget to write the SI in it. It is very important. So right now you have found the number of moles for barium peroxide. Now let's find the number of moles for hydrochloric acid. Now for hydrochloric acid, they have kind of like twisted the question. So they have said that this barium peroxide, the barium peroxide, it reacted with 25.5 milliliters of what? Of hydrochloric acid, which is represented by HCl. And then they have also said that this same hydrochloric acid, it is also containing, the solution, which is the mixture of these two, it is containing the mass of they have said that it is containing 0.0277 grams of hydrogen per milliliter. It is containing 0.0277, they have said, grams per milliliter. Now this statement here is where now they have twisted the question. Here, this one, per meter, where there is per, you can simply replace with this, the slash. So here it's like they are saying that it is having 0.0277 grams per meter. You can just use a slash, per milliliter. Now, so meaning that they have indirectly given you the density. Okay, so we have the density of hydrochloric acid in that solution, even the mass of hydrochloric acid, the volume. So we have the volume, let me just actually write it here. We have the volume of hydrochloric acid, and we have the density of hydrochloric acid. Now the goal is to find the number of moles for this. How do we find the number of moles? Number of moles will require us to use the mass. Actually, it's mass over Mr. E. Mass over molar mass. Mass over molar mass. So now they want us to have the mass and the molar mass. The molar mass of hydrochloric acid, it is basically you can easily find it. Now what we need to know is the number of moles. So we can easily first find the mass using the formula for density is equal to mass over volume. Okay, and then you make mass the subject of a formula, meaning that you're going to have mass is equal to density times the volume. Okay, now I know you might be asking, okay, since it is in milliliters, shouldn't I convert it to liters? So in the case where the density is also having milliliters here, you don't do anything. Okay, so you're just going to directly multiply the volume that is given, you multiply with the density. whatever you get will be the mass for this hydrochloric acid. So let me just do that now. So you're going to say that mass is equal to, density, which is 0.0277 times, it is actually grams per mole, per milliliter, times the given volume, that is 25.5 milliliters. Okay, so this can easily cancel. You're just going to remain with grams. So when you multiply this, you're going to get the mass of 0.7063 and 5 grams A. Okay, so let me just write this on another page. Okay, so now finally we've managed to find its mass. Now we have the information that we can use to find the number of moles for hydrochloric acid. So now we can proceed and find the number of moles, because we can easily find the molar mass of hydrochloric acid. Okay, so using dimensional analysis, you're going to say 0.70635 grams times, actually before I even proceed, let me write the molar mass. So the molar mass for hydrochloric acid is going to give you 36.5 grams. Okay, so now using dimensional analysis, you're going to say 0.70635 grams times 1 mole over 36.5 grams per mole. Okay, then now you're going to cross multiply, and then you're finally going to end up with 0.70635. Since the mole shouldn't be here, you're just going to have the gram here so that it can cancel with that one there. Then you're going to have 0.70635 divided by 36.5. Okay, now when you divide this into this, it's going to give you that is 0.01937 moles. Okay, so now you have the number of moles for hydrochloric acid, which is which is this one here, and the number of moles for barium peroxide, that is this one here. Okay, now remember to find the limiting reagent. So now you are going to write the formula again. So the formula is that barium peroxide, which is a solid, reacted with hydrochloric acid, and they gave us H2O. Not H2O. This is hydrogen peroxide, and then now to find the limiting reagent, you can remember I said that you need to find the number of moles of a certain product A using the number of moles for each. Okay, using the coefficients. So you're going to check the product. So be careful when you're picking the product. You need to pick the product that is having both the elements that are found in both. In our case, this one here, it is having hydrogen that is found here and oxygen that is found in this one here. So you can pick this one. Even this one here, it is having barium that is barium that is found in this reactant and chlorine that is found in this reactant. But there are some cases whereby maybe the product, let's say if the product was like hydrogen, or maybe the product was just oxygen. You don't have to pick those. No, pick those that are having the elements that are found in. That are found in each one of the reactants. Okay, there'll be some equations. You need to be very careful. Don't pick whereby maybe the compound or the product is not having the elements that are found in both. Don't pick that one. If you just had oxygen A, don't pick oxygen. Okay, there'll be some cases like that. But in this case, you can just pick any. Now, I'll just pick barium chloride. Okay. You're going to use now the coefficients. So first, let's begin by picking barium peroxide, and I will be using barium chloride. You can just pick any. Okay. So I'm going to get the coefficients. What number is in front A? There's just one, right? How about A? There's just one. Okay. So now, when you write the coefficients, this coefficient is representing barium oxide 2, and this one is representing barium chloride. Now, remember, you're looking for the number of moles for this one here, using the number of moles for this one. First, you begin by looking for the number of moles of the first reactant, then you proceed to the second reactant, then the one that will give you the lowest will be your limiting reagent. This is a standard method of finding the limiting reagent. Okay, so here you have 1, and then what's the number of moles for barium peroxide that you found? You found it to be, that was it was 0.008565 moles. Okay, and then for this one, you don't know it. You're going to cross multiply. You're going to have x times 1, that is, will be just x, right? How about 1 times this one? It will just bring it back, right? So the number of moles for this are the same. Will still be the same. Okay, so you're going to get 0.008565 moles. Now, here's the tricky thing. What I used to do is that if I just see that here I'm having the same coefficients when I write like this. That's why I like writing like this, because it will help me to even know how the answer will come out. So I just used to know that, okay, if I write the coefficients in this pattern, you just check, okay, are they the same? Even if here there was 2 and 2, just know that it will just come back. Okay, even if maybe if there's just 1 and 1, then I'll just know that, okay, I just need to show the lecturer how I found it, but in my mind I even know the answer. I mean that I won't spend much time calculating. I'll just write it very quickly. That's one thing about this trick. So just check if the coefficients are the same, the number of moles it will come back. Okay, I mean for a certain reactant that you're using, in our case we're at barium peroxide, just know that it will come back if they have the same coefficients. But if they are different, like in the case where we are going to use hydrochloric acid in the same barium chloride, if you see hydrochloric acid is having the coefficient of 2, but this one is having the coefficient of 1. In this case, this is where now you need to use the calculator. Okay, it will even help you to know where to be faster, so that you don't make unnecessary mistakes. That's why practicing is very important, because it will help you to know where you need to rush and where you need to take your time. But in this case, it's better you rush, because you just copy and paste. You already know the number of moles. Okay, so now you do the same even here. So you write for HCl, in front of HCl there is 2, right? The coefficient of 2. How about in front of barium chloride? There is just 1, right? Let me first write it itself. So I write barium chloride, and then I'll say the coefficient is just 1. The number of moles for hydrochloric acid, it is the one that we have just found here, and that one is 0.01937 moles. Okay, and for this one here, you don't know it, right? When you cross multiply x times 2, it is going to give you 2x, and then this number here times 1 here, you're cross multiplying the same thing that I did here. It is going to give you the number itself, right? So it's going to come back. You're going to have 0.01937 moles. Okay, then now you divide by 2. You divide by 2. I'll show you now another way, which is a shortcut. So you're just going to this divided into this, it is going to give you, so it is going to give you 0.0096 moles. Okay, so it will give you these number of moles, and then so after when we used barium peroxide, we got this number of moles A. When we used hydrochloric acid, we got this number of moles A. Okay, so we are going to check which one is the smallest A. Which one? It is this one A, right? So barium peroxide is the limiting reagent. Now, there is a shortcut method that I have observed, whereby just because you have found the number of moles for this one and this one, you quickly divide them. You divide them with their coefficients. Let's say where I have found, where I have, let's say when I found the number of moles for barium peroxide, when I found that it is this one, instead of doing the cross, I just say, okay, I now divide by the number that is in front A, which is 1. You quickly divide. Even for hydrochloric acid, you check that, okay, this is the number of moles for hydrochloric acid is 0.01937. I just divide by the number that is in front A. Yes, this method works, but it has some limitations. From my experience, I once experienced faced some scenarios where I wasn't getting accurate results. So behind the scenes, this method, it uses the same method because as you can see, I still had to divide this by 1. Okay, even if you use that method, would have gotten the same answers. Even A, I still had to divide by 2. So behind the scenes of that shortcut method, they use this formula A. Now there are some cases whereby maybe A, if you had the number like 3 and 2, if you had the number like 3 and 2A, meaning that A you would have adjusted 2 and A you would have adjusted, I think, let me just say, if you had like 3A in front, you would have adjusted 3A and 3A. You see, and you would have gotten the same result. So use that shortcut method in a case where you observe that the product that you have picked is having 1 in front. Okay, only if it is having 1, that's when you can use that shortcut method. Don't even go through whatever I was doing here. Just check, okay, like in our case here, I picked barium peroxide, and I know that the number of moles, which is this one here, I check, okay, I'll pick barium chloride. Since barium chloride, it is having 1 here, you just directly divide by the coefficient of this one, okay, directly. Instead of going through, no, you cross, you do what, and then you also come back to this one here, since it is having the coefficient of 2, and the product that I've picked is also, is having the coefficient of 1. Quickly divide through. Okay, don't waste your time doing whatever I was doing. But in a case where you observe that, okay, the product is having a coefficient in front which is not 1, go through the procedure that I just showed you if you want to get accurate results. Okay, so the other method, it has got some limitations. I once faced some limitations, but yeah, but oftenly it works. But there will be cases where you'll be having like different answers from your lecturer, where you get a different limiting reagent. So normalize using the standard method that I just showed you, but use the shortcut methods in cases that I have just talked about. Okay, so this is how you find the limiting reagent. And actually, I know like 5 ways of finding the limiting reagent. I think I'll be recording some videos. I know many ways of finding the limiting reagent, and these, I think, are the most simplest way and the standard ways. Okay, I'm focusing on teaching the standard methods which are globally accepted, which can be marked by any lecturer. Okay, and maybe in a case where maybe let's say for a product, if they give you like concentration, they just give you concentration in volume. Use the formula, which is concentration is equal to number of moles over volume. You make number of moles your subject to a formula. You're going to say number of moles is equal to concentration times the volume that is given to find the number of moles. Okay, let me just, I just wanted to talk about this because there are some questions which are phrased like that. Maybe in a question they might just give you about the reactant, the concentration, and the the volume of that reactant. It's not always they'll give you the number of moles directly. So it is you to analyze the question. You need to carefully read the question, see the information or the details that they have given you about each reactant that is involved. Okay, so now let's solve for question C. Question C, they're saying that what mass in grams of hydrogen peroxide, which is this one here. So another thing, the key secret now, if you find the limiting reagent, let's say this one which I've just found, if you want to find the mass, or after you find the limiting reagent, if you want to find the mass or the number of moles of any of the species that are involved, or the reactant or the product in the equation, use the moles for the limiting reagent, because the limiting reagent, like I gave you the example, that's where all reactions depends on. Once the limiting reagent depletes, even the chemical reaction do what? Depletes. So whatever product they tell you to find, use the limiting reagent. Don't use the one that is in excess. In our case, the one that is in excess is the hydrogen chloride. Okay, it is the one that is in excess. So use the limiting reagent. So in our case, they want us to find the mass for this one here. Now, we don't know anything about this one here, so we're going to first use the number of moles for this one, the limiting reagent, to find the number of moles for this one here. Okay, since we are using the limiting reagent because that's where the reaction depends on. Okay, so this one we don't use this one. If you use this one here, the one that is in excess, you get the wrong answer. Yes, very important. So now you're going to do likewise. What's the coefficient for that one? It is 1, right? And the coefficient for the other one, it is also 1. So once you just see that they are having the same coefficient, just know that the number of moles for this one is going to come back. It will also be the number of moles for this one. If you want, you can proceed if you get some trust issues. Okay, so if you want, you can confirm. You cross multiply. You still get the same answer. So I'm giving you the tips because on stoichiometry they like giving like a lot of questions and you'll be required to solve in a short period of time. So these shortcuts that I'm giving you will really help you, and they really helped me a lot to not spend a lot of time on a question. So this will also be the number of moles for this one here. Now I'm looking for its mass. Right now I have the number of moles. Okay, so you can behind maybe a piece of paper you can say number of moles is equal to mass over Mr. to just help you remember what the details that you need to find the mass. So you need the number of moles and the molar mass. Okay, but don't use this one unless your lecturer allows you to use this formula. Use dimensional analysis. If you don't know how to use dimensional analysis, I think I'll make a video about it, but I've already taught that in my group. You can find the videos there. So which is a widely accepted method. So now I'm looking for the mass, right? You know that, okay, if I'm looking for the mass, I need the molar mass, meaning that I'll just need to somehow eventually multiply. This formula will just help you to know how a certain quantity is going to be found. But don't use this one unless your lecturer allows it or has used it during the lecture. If you didn't use this method, don't use it. You'll mark it wrong. You get the answer wrong. Okay. So now we need to find the molar mass, and how do you do that? You know what to do. Oxygen, since that is 16 times 2, oxygen that is 2 times 1.01, and when you add this, you're going to figure out that you're going to have 34 grams per mole. So the molar mass is 34 grams per mole. So right now you have the molar mass and the number of moles, which you have just found. Okay, so now you're going to use now dimensional analysis. You know, okay, I already have the number of moles, that is 0.00865 moles times 34 grams over moles per mole. The moles are going to cancel. You're just going to remain with this one times 34. And when you multiply this with that one there, you're going to get 0.291 grams since you're just going to remain with the gram A. So you have found the grams for hydrogen peroxide using the number of moles for the limiting reagent, to find the number of moles, of course, for hydrogen peroxide. Okay, so we have answered question C. So now, question D is saying that how many grams of the reactants in excess will be left over? Here is what it means. So they want us to find the mass of this one, which remained in excess, right? So remember, it was in excess. So to find this mass, first of all, we need to find its moles. The moles, first we need to find the moles that were used up. Okay, in this case, we need to find the moles that were used. Since we know the number of moles that were used up to produce whatever product for the limiting reagent. The limiting reagent, it is the one that depleted first. So its number of moles that reacted to form any product were the ones that were used up in a reaction. So with that information, we can use the number of moles for barium oxide to find the number of moles for hydrochloric acid. Ignore those number of moles that you just found initially. Okay, those were like okay, don't ignore them, but at the moment we're going to ignore them. But we're going to consider them. But that number of moles which we found to be, I think, let me just write it down here. So these number of moles were the initial number of moles for hydrochloric acid. Yes, they were the initial ones. Before the reactions, these were the ones that were present. Now they want the one that remained, meaning that some moles were used up to produce the product. Okay. Now these were the initial ones. Now we want to know after the moles that were used up. Let me just say, if we subtract the number of moles that were used up, that's when now we are going to get the ones that remained. So meaning that first we need to find the number of moles that were used up, and then to find the number of moles that remained, we are going to subtract the number of moles that were used up from the initial number of moles before anything before any moles were used. Okay, the ones that were there before even the reaction started for hydrochloric acid. And the way that you find that is using the limiting reagent, because it is where the reaction depended on. So the number of moles that were present were the number of moles used up in a chemical reaction. So with that being said, you're going to get the coefficients of these two. For barium peroxide, we know that it has the coefficient of 1. Hydrochloric acid is having the coefficient of 2. This one, we know its number of moles, and we know that it is 0.008565. Okay, this one is what we're looking for. This time we are looking for the number of moles that were used up. They ask you to find the number of moles that for this one that were used up. You do what I'm doing right now, but they want the one that were left over, that left. Okay, so you're going to cross multiply. You're going to have x. This times that one there, you're going to get 0.01713 moles. Okay, so you're going to get this. So these are the number of moles for this one that were used up. Remember, it was in excess, like I gave you the example. So if you relate it to the example that I gave you for pairing the boys and the girls, so these were the guys that were successfully paired. Okay, now they want us to find the guys that remained single. They didn't have anybody to be paired with from the limiting reagents, which were the girls. Yes. So right now we have just found the ones that were used, that were paired in according to that example that I gave you. It's a very powerful example, that one. Okay, you understand this topic. Again, if they told you maybe like, okay, find the mass of the reactant uh, that were used up for hydrochloric acid, if they told you about the mass, you know that mass is equal to, I mean, number of moles is equal to mass over mass over molar mass. You know that you're just going to multiply this number of moles times the molar mass for hydrochloric acid, which is I think 34. Okay, you even find the mass of whatever, the mass of the hydrochloric acid that was used up. Now, in this case, they don't want us to find that. They want us to find the ones that remained. Okay, so I think let me just find it for you. If let me find the mass. Actually, I'll show you two ways of solving this question. There are two ways of solving this question, but for now, I'll be using the number of moles. I'll show you the other one for using the mass. Let me just finish using the number of moles, then I'll show you the one for using the mass. Okay, so we found the mass, the moles that were used up. Now, having found these moles, to find now the one that remained, you're just simply going to subtract now. You're just going to say, okay, I know that initially there was, before and even the reaction started, there was 0.01937 moles. Now, this one, it's like they removed them, okay? They were removed. Now, which one remained? To find the moles that remained, you're going to subtract 0.0193 minus 0.01713, the one that you've just found. Okay, so now you're going to say this one minus this one here, or this one minus this one here. You're going to get the moles over 0.00224. Okay, so now that you found the number of moles, which is 0.0224. So now to now find the mass. Right now you have found the number of moles for hydrochloric acid that were left over. Okay, after you subtract from the initial one, after you subtract the used one, which we found here, minus the initial ones, you get what remained or what was left over. So now, since you already have the number of moles, and if you remember that formula, that number of moles is equal to mass over molar mass. Oh yeah, even though we're going to use dimensional analysis, but we're still going to be referring to this one here to just help us know the information that is needed to find the mass. So to find the mass, you know that you need the number of moles and the molar mass. And the molar mass for hydrochloric acid, it is 36.46, okay, grams per mole. So now you have the molar mass and the number of moles. You can easily find the mass. So you can just say mass is equal to the number of moles, that is 0.00224 moles times 36.46 grams over moles. In the moles, you're going to cancel. Now you're just going to remain with 0.00224 times 36.46. When you punch this on a calculator, you should get 0.0817 grams. So now these are the grams of hydrochloric acid that were left over, okay, that were in excess. Okay, now this is just one method. In books you'll be seeing them using this. Now let me show you another way that you can use. If you don't want to work with the moles, you can work with the masses. Let me just show you. Okay, so for this one, after you find the number of moles using the limiting reagent, which we found to be, it was 0.01713, okay, moles. So now these were the number of moles that were used up in excess. So you can just convert now this number of moles into mass, And even if they told you maybe to find the number of moles that, the mass that was used, you can just enter. Let me just find the number of moles. The mass of the moles that were used up. So you can find the number. The mass of the moles or that were used up. So you can just say 0.01713 times 36, and that's going to give you 0.625245 grams. So this, if they told you maybe to find the mass of hydrochloric acid that was used up, you just end A. This is what I was talking about. And then now, since we're looking for the mass that remained, that was in excess, you are going to get the initial mass. Remember the mass that we found when we were given the density and the volume. Do you remember that mass? And that mass was 0.70635. So this was the mass that it initially had, that hydrochloric acid initially had. So you're just going to get that mass, and you're going to subtract now the mass that was used up from the initial mass. Okay, what you're going to get will be the mass that remained. So this was the mass that was there initially, and then minus the mass that was used up to produce the product. It was 0.6252524. Okay, now after you subtract, you're going to get 0.0817 grams. So this is another way. In some books you'll be seeing them using this way or the other way. So there are two ways. In both ways will still give you correct answers. Okay, so now let's look at the last question, the percentage yield. Now let's solve the last question. Saying that if 1.34 grams of barium peroxide, chloride, were produced, calculate the percentage yield for barium chloride. Percentage yield is calculated using the formula percentage equal to the actual yield over the theoretical yield times 100%. Now, what is percentage yield, first of all? What is the actual yield and the theoretical yield? What are these? So, in a reaction, let's say maybe I want to react A with B. Okay, I want to react these two so that I can produce AB. So, the chemists always they do some sort of analysis. They will check the reactants. Looking at the mass of the reactants, they try to predict that, okay, looking at maybe let's say I have 2 grams of A and 3 grams of B. They can try to predict that, okay, we might get maybe like maybe between 4.5 to 5 grams of the product, because we are reacting 2 grams of A and 3 grams of. Okay, so they will like come up with an approximation, like, okay, I think we might get like 5 grams. So this one is not proven. It is not the actual mass of what is produced. This is just a theory. A theory is not something that is real. Okay, it's more like a prediction. They are trying to predict based on the reactants. So this is what is called the theoretical yield. Okay, and then the actual yield now is what they actually get after the reaction happens. And you know, the funny part is that they don't come out to be the same. So now scientists came to observe that when this happened, well, let's say maybe in this case, let's say maybe they produced like 3 grams. Okay, so 3 grams, it will be the actual yield. It will be the actual yield. It is the one that has been actually produced. Actual coming from actually. Okay, theoretical yield. So now, scientists came to observe that oftenly the actual, like 99% of the times, the actual yield happens to be smaller than the theoretical yield because they have a lot of expectations. Because okay, I'll explain. Maybe let me just talk about the actual one. So they observed that the actual one happens to be smaller than the theoretical one. Okay, and that's why they came up with this formula, with the smallest one being on top and the biggest one being there on the denominator. But why does it reduce? Because it happens that maybe all they react and they don't react. Maybe one depletes quickly, the others just remains. The ones that are in excess just remains there pending. Okay, or maybe even if they were all to react, maybe some moles might diffuse during the reaction. Maybe some moles might be lost. So it might happen that what they predicted doesn't actually come out. Okay, so it usually reduces. That's why the formula is like actual yield over theoretical yield. The purpose of having the smallest one on the numerator and the biggest one on the denominator is to be able to get the percentage. Remember, percentage should not be above 100%. Now, there is a funny thing that happens here. There are some questions which are confused, whereby you're going to find that the actual yield is bigger than the theoretical yield. And when you punch on your calculator, you're going to get maybe like above 200%. So I said that 99% it happens that the actual remains very small. So now, if you are in a case whereby the actual one is bigger, just swap them. Okay, they won't mark you wrong. No, you just swap them so that you don't get the percentage that is beyond 100%. Or in another way that I can explain, if you want to place the actual there where it's supposed to be, but if you get maybe after you punched all this, you evaluate and you find that you get the percentage that is above 100, just know that you need to swap the positions. Okay, don't just master them the way they are. No, some questions don't know where they get those questions from, but it happens that in a question, maybe you get the one, you get the percent that is above 100%. Now, how do you find now the actual in the theoretical yield? So when you look at this question that you have here, they have said that if 1.34 grams of barium chloride were produced, so the one that they say in the question that they were produced, this was the one that was actually produced. Okay, so in short, what you need to know is that the one that is found in the question is the actual one, the actual yield, the actual mass that was produced. Okay, so in our case here, the actual one, it was 1.34. In case maybe you're getting confused, so the one that is found in the question is the actual one. Just know that. Okay, no matter how they phrase the question, just know that the one that they put in the question is the actual one. And then now they are saying that calculate the percentage yield. So they won't tell you that find the theoretical yield. To find the percentage yield, you always have to find the theoretical yield. And how do you find the theoretical yield? To find the theoretical yield, you're going to use the equation. Okay. In short, the theoretical yield now is the one that you calculate. You as a student, you are solving. The one that you're going to calculate using the limiting reagent, and we have already found that one. Oh, we haven't found it. Oh yeah, but let me just say the one that you're going to find using the limiting reagent is the theoretical yield. So the one that you find is the theoretical. The one in the question is actual. So now let's find the theoretical yield. Let me show you how you find it. So you're going to look at your equation. Okay, so now to find the theoretical yield, you're going to first find the number of moles. Remember, we want to find for barium chloride, right? So you're going to write your equation that is barium oxide plus 2HCl and H2O 2 plus barium chloride. So you're looking for the moles for the barium chloride, right? It has a coefficient of 1. we are using the limit in reagent, which is this one here, and it also has got one coefficient, but the number of moles, it is 0.008565. This one is x when you cross multiply, but you can just see that, okay, since they have the same coefficients, even the moles will be the same. So even barium chloride has got the moles of 0.008565. Okay, now you know the moles. You are looking for mass, right? Remember, the yield is in form of mass. So since you know the number of moles for barium chloride, you can now easily find the mass. You're just going to say, okay, 0.008565 moles times, and when you look, I mean, when you do the calculations, you find that the molar mass for barium chloride is going to give you 208.327 grams per mole. Okay, so the moles are simply going to cancel, and when you multiply, you're going to get 1.78 grams. Okay, so you find the mass for barium chloride. So this mass that you have found is the theoretical yield. The actual yield is the one that is in the question. So you're even going to use the formula, which is actual over theoretical times 100%. And you're going to write 1.34. You're going to write 1.34 over 1.78 times 100, and that is going to give you, it's going to give you 75%. So this is how you find the percentage yield, and I hope that you have understood. And I think this is all for this video, and make sure that you try to solve more questions from the past papers applying the concept that I've just taught you. And don't forget to subscribe, and for more video lessons, don't forget to join my Telegram group. So this is Joseph here. Okay, so these are the groups where you are going to be added once you subscribe to the official group for A+ Academy. As you can see, there is a group for MA110 there. In each group, I upload video lessons which are recorded. All these video lessons have been uploaded, and I still upload them. And in every lesson, I make sure that I solve tutorial questions, especially the most asked questions, so that you can learn and watch at your own pace and revise. Even our physics video lessons are already there. Okay, and our chemistry, everything is in the group, and the lessons are very organized. You'll be easily learning. Okay, so even biology, the lessons are already there. There are a lot of videos. You'll be just watching them at your own pace. And not just that, there is also this group for A+ Academy solved documents. So this group you also be added once you subscribe. So this group is where I upload all the solved materials. Okay, even the documents that haven't been solved, starting from last year's past papers and tutorial sheets, I've solved them all. Remember, that's where the questions come from, and oftenly they repeat questions from the last academic year. So I've already solved all the documents. Even the tutorials that they'll be releasing, I'll be uploading them in the same group together with the assignments and the lab reports. They'll all be uploaded in this group. So once you just subscribe, you'll be added in all these groups in just a single subscription. So make sure that you subscribe